February 6, 2020. Professor Monica Grady, a leading British space scientist, stated something astonishing about the prospects of life beyond Earth during her talk at the Liverpool Hope University. The professor believes there could be higher forms of life beneath the ice on Europa, perhaps similar to the intelligence of an octopus. Europa, the smallest of the 4 moons orbiting Jupiter, was first discovered in 1610 by Galileo Galilei. It has a radius of 970 miles, making it slightly smaller than our moon, which has a radius of 1,080 miles. On average, Europa is 390 million miles away from Earth. The median ice thickness of the moon is 25 miles. The average temperature is minus 260 degrees Fahrenheit. And at that temperature, no living creature should be able to survive, but Europa hides something incredible under its icy outer shell. NASA's space probe, Galileo, discovered Europa's induced magnetic field, which indicates the presence of a global, electrically conductive fluid layer beneath the surface, most likely a saltwater ocean. The icy shell shields everything underneath it from cosmic radiation and direct impacts from comets and asteroids. Though different in what they're comprised of, the icy shell provides similar protection to what the atmosphere does for planet Earth. Think of Europa as a moon-sized incubator. It's estimated that Europa's ocean under the ice may contain twice as much water as Earth's global ocean. That's incredible considering Europa is only 1/4 the diameter of Earth. We also believe that Europa's ocean is 10 times deeper than the deepest part of Earth's ocean, and the temperature is on par with that of Earth's ocean at the poles, which lies in the range of 25 to 32 degrees Fahrenheit. The makeup of Europa's ocean is likely similar to that of the Earth's. Scientists believe it's sodium chloride salty, making it highly likely that it's able to support life. So much so that Professor Grady stated, "When it comes to the prospects of life beyond Earth, it's almost a racing certainty that there's life beneath the ice on Europa." The reality is that the possibility of life existing on Europa is a long-running debate in the scientific community. Scientists first hinted at the possibility of a global ocean beneath Europa in 1979 when Voyager 1 and 2 flew by the moon and took close-up images. Subsequent observations by other space probes showed even more evidence of life under the icy moon. NASA's Hubble telescope and large Earth-based telescopes have reported detections of faint water plumes or their chemical components at Europa. Europa is geologically dynamic, meaning the ice-covered moon generates heat inside as its solid layers stretch and flex from the gravitational tug-of-war with their host planets and neighboring moons. This, instead of heat from the sun, keeps subsurface water from freezing. The heat may also help produce or circulate life's chemical building blocks at their seafloors, including carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur. That said, a more recent study suggests that Europa's seafloor may not be geologically active enough for volcanoes. So, as aforementioned, the debate is still ongoing. Images from the 2 Voyagers revealed a surface brighter than that of Earth's moon, crisscrossed with numerous bands and ridges, and with a surprising lack of large impact craters, tall cliffs, or mountains. In other words, Europa has a very smooth surface relative to the other icy moons. The plumes of water vapor shooting off the surface of Jupiter's moon were more than 200 meters high. If you follow in through the hole of the plume, you'll traverse through 25 miles of its outer icy shell, and when you reach the end, its ocean will appear, and you'll find that the deepest part of it will take you to the depths of 100 miles. In contrast, the deepest part of our ocean, which is the Mariana Trench, has a maximum depth of around 7 miles. Undoubtedly, sunlight cannot penetrate the thick icy shell of Europa. Therefore, life through photosynthesis is impossible. However, examples of life in our own planet's deepest ocean reveal that life can indeed exist without photosynthesis. Life in the deep ocean around underwater volcanoes, known as hydrothermal vents, is diverse and has adapted to extreme conditions. These environments can have temperatures ranging from 35 to 750 Fahrenheit, high pressures, and toxic levels of hydrogen sulfide and heavy metals. They are also dark due to their depth, and organisms that live there don't rely on sunlight for photosynthesis. Instead, they use a process called chemosynthesis to convert chemicals in the water into energy. Microbes that survive by harvesting chemical energy from the hydrothermal fluid form the base of a unique food chain that includes tube worms, shrimp, and even crabs that live in communities around the vents. Scientists suspect that Europa could harbor life through the same process. Though currently we haven't confirmed that life exists in Europa's ocean, it is a scientifically accepted fact that the presence of a global ocean increases the odds of it harboring life. Perhaps this is the most important factor which convinced Professor Grady, along with many of her colleagues, on life, such as octopus existing in Europa's ocean. Note that octopuses are a lot smarter than people imagine them to be. Humans are the smartest vertebrates on our planet, but octopuses are our counterparts among the invertebrates. In short, they have the IQ equivalent of a 3-year-old human being. The genome of the octopus shows a staggering level of complexity with 33,000 protein coding genes, more than are present in Homo sapiens. It is no wonder why so many people think the octopuses will inherit the Earth if humans ever become extinct. A film called Europa Report was released in 2013. It was about a mission sent to Europa to once and for all prove the existence of life in its ocean. Earth sends a spacecraft to Europa, which drills through the crack on the moon's icy shell to investigate for signs of life. There, they come across an octopus-like mysterious creature, and the main story is how the crew contends with it. From start to finish, the film portrayed the space mission as realistically as possible. This has a lot to do with the fact that the filmmakers brought in 2 science advisors, a JPL astrobiologist geophysicist Steve Vance, and an astrobiologist planetary scientist Kevin Hand to advise on everything from Europa terrain, its likelihood for life, radiation exposure, and realistic portrayals of mission operations and scientists. Both renowned scientists in their own rights are also in agreement that Jupiter's moon Europa may create the conditions for life in its global ocean. If life exists in Europa's ocean, then they would have evolved similarly to the creatures in our own ocean. Perhaps the creatures there have evolved to breathe through their gills. Maybe they have fins in place of fingers. Different types of fish might exist, and of course octopuses and even dolphin-like creatures may thrive under its icy shell. There's a book called Fleet of Worlds, published in 2007 and written by Larry Niven. The book introduces us to an intelligent alien species known by the name Gwoth. The Gwoth resemble starfish and inhabit the ocean under the ice of their home world, the moon, Jamho. The description of their home world is very similar to that of Europa's. Indeed, the writer's inspiration for the icy homeworld came from Europa. At some point in the story, some enterprising Gwoth learned to fashion watertight leather suits that can circulate water to and from the suits with leather hoses pumped by leather bellows. This allows them to surface above the icy shell of their planet and encounter the stars for the first time. Could we ever witness something similar happening on Europa? Though it's unlikely based on our current understanding of the prerequisites of life evolving into an advanced civilization, for example, the inability to make fire underwater. We'll soon learn more thanks to NASA's Clipper mission, planned to launch in October 2024. Scientists have designed the Europa Clipper mission to conduct multiple flybys of Europa to sample different aspects of the moon's magnetic response. Through this, they hope to work out the salinity of the ocean. The Europa Clipper possesses a range of instruments that will gather materials ejected from icy geysers on the moon. and those materials could provide astrobiologists with credible evidence that living processes are indeed occurring beneath the surface. Europa's ocean may have existed for the entirety of our solar system's history. This is according to NASA. Approximately 4 billion years is sufficient time for life to develop. Who's to say that in all of that time, a species as intelligent as octopuses couldn't have evolved there? Hopefully soon we'll have the answer.